Welcome everyone, myself Ankita. Today we will be discussing about some important questions on capacitance, inductance and resistance. As previously we have discussed so many questions on basic electronics, electrical measurements, applied mathematics and electric circuit and network. These all. So if you have not watched that videos, you can go and check that videos. Otherwise I will also provide that videos in my description box. So here we will start here from our first question. Our first question is, inductor does not allow the sudden change of. We should know that inductor, we all know that V equals to L di upon dt. So it, in inductor, it doesn't allow the sudden change of current. So here the current is changing, so our it doesn't allow the change of current. So our A option will be our correct answer. Now moving towards the next question. Our next question is, capacitor does not allow the sudden change of. We should know that capacitor, I equals to C dV upon dt. I equals to C dV upon dt. Here the voltage is changing. Here voltage is going to differentiate like dV upon dt. So in capacitor, voltage capacitor does not allow the sudden change of voltage. I mean that voltage should not be changed like directly. So here option B will be the correct answer. Now moving towards our next question. Our next question is, internal resistance of ideal current source is. We all know that internal resistance of ideal current source is infinite, but here if it will be ideal voltage source, if it will be ideal voltage source, then it will be 0. But here is ideal current source. So here B option will be our correct answer. That is infinite. Now in our next question is, nodal analysis can be applied for. We all know that what is nodal analysis. We have also discussed in Kirchhoff's voltage law. Previously we have discussed it. If you have not watched that video, you can go and check that video in my profile. So here we will discuss this question. Nodal analysis can be applied for. Nodal analysis can be applied for both planar as well as non-planar networks. It means 3D and as well as 2D networks, planar as well as non-planar networks. Our C option will be our correct answer. Now in next question, mesh analysis is applicable for. Mesh analysis we have also discussed in our previous videos. So mesh analysis is only applicable for planar networks. It is not applicable for planar and non-planar both. It is not applicable for non-planar. So it should be remembered that mesh analysis is only applicable for planar and nodal analysis is only applicable for non-planar. Our next question is, superposition theorem is not applicable for. We all know that superposition is applicable only for current and voltage, but it does not applicable for power. For power calculation, for measuring power, it should not be applicable. So our C option will be our correct answer. Now moving towards our next question. Our next question is, to apply reciprocity theorem, response to excitation ratio is. For applying reciprocity theorem, we should take both. We can take both units like mho, or we can say it Simon, Simon or Simon, mho or ohm. We can take both. For reciprocity theorem, response to excitation ratio is either ohm or mho. So our D option will be our correct answer. Now moving towards the next question. Our next question is, which quantity should be measured by the voltmeter? It is very simple question, because we all know, we have also discussed in our previous video that voltmeter measures only voltage or potential difference, but ammeter measures the current. Like we can write it as ammeter measures current, but voltmeter measures V, voltage. So here our B option will be our correct answer. Now moving towards the next question. Our next question is, which quantity consists of a unit 1 kilowatt hour? We all know that power equals to energy upon time, or work by time, we can also say that. So energy equals to P into T. P equals to P has the unit kilowatt, or watt you can also say, but kilowatt is a standard. Kilowatt into time hour. So 1 kilowatt hour, which is giving us energy. Our energy will be our correct answer. Now moving towards the next question. Our next question is, instantaneous power in inductor is proportional to. We all know that in instantaneous power, P equals to instantaneous power is proportional to current and rate of change of current. So here our A option will be our correct answer, product of instantaneous current and rate of change of current. So A option will be our correct answer. Here our question ends. Now we will discuss in our next video. And hope you will like this video. If you like this video, then please like, share and subscribe, and thank you for watching.